Today we're talking about direct variation. Direct variation is a specific relationship in which there is a constant ratio between all ordered pairs. Your ratio is written in the form of y divided by x. Okay, direct variation equations are written in the form of y equals k times x. Your k is your constant. I don't know why it's k. That's just what it is. So our ratio of y divided by x is our constant. This is basically the slope equation, just there is no y-intercept for direct variation. It is just your slope times your x value. So to find our constant, you need to take your y value divided by your x value. So you would take your y value divided by your x value, y divided by x, y divided by x, y divided by x. No matter which one of these you pick, you should get the same exact number if it is a direct variation. So it doesn't matter what you pick. I'm just going to use the first one. You can use whatever. Double check your work. Okay, so 4 divided by 1, which equals 4. 8 divided by 2 is 4. 12 divided by 3 is 4. 16 divided by 4 is also 4. So I do know that this works. So I'm going to go ahead and put this in my y equals kx. So I have y equals my k, which is 4, times x. This is my equation. Okay, so we found the constant by doing division, and then you just put this in where the slope goes to get 4x. So that is my equation for finding this constant. Easy enough, right? So we're going to do the next 3. So follow along, think ahead, try and guess what it is before I tell you. Okay, so for 2, again, you're doing your y divided by your x. Y divided by your x. For 0, 0, since you can't divide by 0, we're not really going to focus on that one because you can't do 0 divided by 0, you can't do that. So we're really looking at the ones that have numbers. However, this is a very good thing to notice because constant direct variations do need to go straight through the origin of 0, 0. So if this point is listed here, then that's a good sign that you could have a direct variation, but you need to make sure you check those other points just to verify. So I'm going to go ahead and do my y divided by x. I'm going to use my first one, k equals 3 divided by negative 6. I know that that simplifies to negative 1/2. Okay, and 2 divided by negative 4, negative 1/2. Negative 1 divided by 2 is also negative 1/2. So I am positive that this is correct. So to put my equation, I'm going to do y equals my constant of negative 1/2 times x. That is my equation. Number 3, same idea, it's in a table now. So still y divided by x, y divided by x, again 0, 0, so y divided by x in the last one. So I'm going to go ahead and do my constant. It doesn't matter what point you pick. They're all going to get you the same thing if they are a direct variation. Negative 8 divided by negative 12 does simplify to 2/3 because a negative divided by negative is a positive. So I know my constant is 2/3. Negative 4 divided by 6, 2/3. 2 divided by 3, 2/3. So I do know that this works out. So I am going to go ahead and put my equation together. So y equals 2/3 x. That's my equation. And then the last one, same idea, tables different direction. Still works the same. Y divided by x, y divided by x, etc. So k equals my y divided by my x. And 12 divided by negative 4 is negative 3. So my equation is y equals negative 3x. Easy enough. So we're going to go ahead and move on to the identifying equations. So this part involves looking at the equation. You may need to rewrite it in y equals kx form. But if you have it in y equals kx form, then it is a direct variation. So for example, the first one, this is y equals kx form. So yes, this is a direct variation, and the 3 is my constant. For number 6, same idea, y equals our constant times x. So my constant here is that. Yes, this is a direct variation. My constant is a negative 4/5. For number 7, I don't have an x here. It's y equals 2. There's no x term, so this is not a direct variation. Number 8, you need to go ahead and solve for y. So I'm going to divide both sides by 2. which is something you should already know. And then I end up getting y equals 5/2 x, which is in fact a direct variation. And my constant here is 5/2. For number 9, I have y equals x minus 4. This minus 4 makes it not a direct variation. You can't subtract 4 or add anything to it if it's a direct variation. Number 10, I have a negative x here. That means my coefficient is -1. So yes, and my constant is -1. For number 11, dividing by 2, y equals 1/2 x. And that is because of the 1/2 is our constant. Okay? For number 12, I'm going to solve it for y. So I have 2y equals -4x plus 6 divided by 2. So I have a -2x minus, plus 3. Okay, so that's a positive 2 we're dividing by. I have a plus 3 here. So it is not a direct variation. And then this one, solving for y again. So y equals, subtract 5x from both sides. So -5x. And this is a direct variation because it's in y equals kx form. And your constant is a -5. So onto the back. I think this is the easiest part. All you're doing is looking at a graph, okay? If it goes through the middle, the origin, 0, 0, and it makes a straight line, it is a direct variation. Okay, so for this first one, it hits the origin, and it is a straight line. So yes, this is. To find the constant, I need to find the slope. So I'm figuring out how much we go up. So it's up 1, 2, 3. And then how much you go to the right, which is 2. So my constant is equal to 3/2. Okay, and then the equation, if you need to write that, but you don't, but it would be that. For number 15, I can say that my graph is a straight line. However, it does not go through that origin. Since it does not go through the origin, it is not a direct variation. And the equation for this line, which you should be able to figure out, is -1/2 x plus 4 because of that y-intercept. For number 16, okay, that is going through the origin and it is making a straight line. So yes, that is in fact a direct variation. The equation for that line is y equals, we're going down 1 and then to the right 4. So -1/4 x, which means my constant is -1/4. Sorry that looks weird. There you go. Okay. And then the last one, it again goes through the origin and it hits every point here, even though these are not technically already on the line, like drawn in. These do all hit, so it goes up 1 and then to the right 1, up 1 to the right 1, up 1 to the right 1. So my constant here is 1. And yes, this is a direct variation. This is the parent function, y equals x. So the most difficult part of this, which is not super difficult anyways, is finding missing values. In order to find missing values for direct variations, you're going to have your ratio equal to your ratio. So for example, for the first one, I'm going to do my y value over my x value equals my y value over my x value. So -4/2 equals y over -6. And then I can go ahead and solve this like a proportion where you cross multiply. So 2 times y equals -4 times -6, which is 24. When I solve for y, I get 12, and 12 is my answer. So it's not too difficult. It is probably the hardest part of this type of problem. It's not really that hard. We've been doing proportions before. Okay, so we're going to do number 19. Same idea, y over x equals y over x. So 16/4 equals 24/x. Same thing, we're going to cross multiply. cross multiply, cross multiply. So 16 times x equals 24 times 4, which is 96. Divide both sides by 16 because that's the next step in solving this equation to get my x value of 6. For 20, same idea, your y over your x equals your y over your x. So 4y equals 12 times 7, which is 84. Divide both sides by 4 to get that y by itself, and we get 21 is our y value. For 21, setting up our y over our x equals our y over our x. Cross multiply, 24x equals negative 16 times 6. Negative 16 times 6 is negative 96. Divide both sides by 24, and you will get a negative 4. Right, a couple more. If y equals negative 18, when x equals negative 3, find x when y is negative 30, or positive 30. Gosh, sorry. So you can rewrite these as ordered pairs if you want. You don't have to. It says y is negative 18, x is 3, equals 30 over x. Cross multiply, divide. Right? Same idea. It's just with words more than just the ordered pairs. So same thing for the next one. We're going to go ahead and do 80 over 32 equals 100 over x. Cross multiply, divide. So I have 80x equals 3,200. Divide by 80, and you get 40. Same thing here. Y divided by x. Y divided by x. And that's how you do direct variation problems.